welcome Nutesh. We're thrilled to have you on the show. To kick things off, could you tell us about your journey? How did you end up at Meta?
Well, thank you for having me. It's a pleasure to be here. I started as a software engineer with Microsoft India, and then I transitioned to Microsoft Redmond, and there was an opportunity to work for Meta, and I just joined Meta. It was called Facebook at that time when I joined, and then later they renamed it to Meta. And for qualifications, I did my bachelor's from Punjab Engineering College, Chandigarh, and from there I got like placed via campus in Microsoft. That's how I ended up at Meta.
That sounds fascinating. So, the main question we're all asking, what are your views on math?
My personal take is maths is very important. It's critical in everyday thinking, anything that you do, any logical reasoning, any decision making, whether it is for your life or work or anything. I think maths, in addition to emotions, is very important.
Did you always enjoy math when you were in school, or like did your perspective about change over time and now you like math?
No, I always enjoyed it. I think I remember when I was back in fourth when I went from school in village to school in town in Sunam DAV, they introduced computers. And at part of that, they introduced basic language and there were very basic programming that you have to do. I was fascinated by the binaries and at learning a little bit advanced concepts outside of the tables and all that. We started introducing a little bit more complex arithmetics in maths. So I loved doing the conversions, convert something to binary, convert it back. So at the same time I was learning math, at the same time I was learning programming, and it kind of was the most fascinating thing for me at that point. I was about 9, 10 years old at that time.
Yeah, so thank you. This also kind of shows how math is used in computer science a little bit.
Yeah, for me it has always gone hand in hand. Yeah.
Yeah. So a lot of people wonder, like, they're learning trigonometry or calculus, and they're like, when will I ever use such bizarre concepts? And have these ever helped you in your career?
They have, and that is not, that's a natural feeling. It also, I often get a lot of this question when I mentor a lot of people, that why do you ask in interviews all these data structure and algorithm questions where in day to day job in coding they don't use that. It's just that how we just have to test how you're thinking, how your rational thinking is, how clearly you can think, how can you break down a big problem and like into smaller problems and solve the smaller pieces and build up on top of that. And mathematics is basically that. It's a bunch of rules that started as very basic thing, and then they were like combined over a period of time to make more complex systems and help bring a lot of rationale and understanding to physics, or even computer science. Computer science is nothing but mathematics and 0 and 1. So if you understand, like, I'm pretty sure that by now you know that computer science is like just bits and bytes. So it has only 0 and 1, and maths has like 1 to 10. So it's a base of 10. I think if you have to put an analogy, human mind is just doing mathematics in the base 10. Computer science is doing at the base 2, just using 2 bits. So those are the basic things, but practically there are a lot of implications, like trigonometry or geometry overall is very important in the designs and the 3D, all the work that happens in the 3D designs and everywhere. In that field of computer science, it's very important. Arithmetic basics is very important in doing anything. The basic algebra is very important in calculating the space-time complexity of any algorithm. What else can I think of? Yeah, I would say that it plays the like very critical and the pivotal part in computer science at least.
Yeah, that makes a lot of sense. Could you elaborate? Like, many people think that coding is just typing random words into a software. Could you elaborate on like the role of logic in math, which helps you in computer science?
And that's a good question. Coding is not just writing random letters. It's like writing stuff into a logical conclusion. That's the core of it, right? So even if you say most of the first coding task in any language is like print a hello world, there is still a logical reason that when you are doing, you're telling the computer to logically do steps 1 2 3, and the last step is print a hello world out on the screen. And most of the time the next question that is usually done is the addition and subtraction. That is kind of the most likely task that you're given in programming, because at the end of it, computers, as I said, is just a brain operating in a 0 and 1, right? So it needs to have a very logical reason or step by step deterministic way of doing things. So it need to know whether I can reach a conclusive end or not. Like the every code that you write usually has a backing flow chart, and every flow chart has a start and a stop, and it can have multiple stops for a single start depending on input, and all of those decision making is all logic.
Yeah, that makes a lot of sense. Do you think math also helps you in your personal life?
It does a lot. As I said in the beginning, I think the logical and analytical reasoning is very important in any decision making. The more you grow in life, you always encounter more gray areas, like where things get a little bit more difficult. In the beginning, things are very black and white or zero and one, where the decision is very clear what's the right thing or the wrong thing, or at least based on the understanding and the learning of others. But both in the personal life and also in professional life, the more you grow, the more you have to deal with a lot of like gray areas. For example, do you want to spend more time with your kids, or do you want to do more job? Like how do you rationalize that decision, right? So you have to do a lot of finances, and all the finances is math. You have to see that you have providing enough for your family, there is enough financial security. So you do all that calculation, and based on that you can choose how much time you want to spend and how much time you want to spend in your kids. That's just one example, but even any other thing, how much a life upgrade can I have, which car to buy, which house to own. A lot of this is tied to finances, which is basic arithmetics at core of it, but a lot of logical reasoning. How do you again break up this big problem into smaller chunks of problem and reach at a conclusion is how you kind of drive the learnings from mathematics and computer science logic.
Yeah, I never really thought about that. Math is basically used everywhere in our lives.
Yes, it is more than you can imagine.
Yeah. So we talked about how the logical thinking skills and these are used in coding which are developed from math. Could you elaborate on how math develops these like essential life skills such as problem solving and logical thinking?
I can take some real life examples if that will help connect the dots
Yeah,
better.
sure.
Yeah. So like I am mostly a backend engineer. I deal with a lot of infra setup, how to, at least for the middle time of my career so far, when I moved to Microsoft Redmond, one of the biggest challenge that we were dealing with is how to shift everything from on-premise to cloud. It might be before you went into computer science a little bit more, like back in 2008 2010 everything was hosted on the physical servers, right? Like the all the data is in the server centers, which are owned by the IT company or the whoever owns it, right? Like Microsoft is selling Office, SharePoint, or whatever. They will host that on their servers, which are owned by the IT company. But then Azure came, or AWS came, or Google Cloud came, there was a big problem to move everything to the cloud, to Microsoft servers. So the data we are talking about is in the order of the petabytes, right? Like which is huge amounts of data, to the point where AWS even had the physical trucks moving the servers from company's data center to AWS data center so that the upload of the data can be faster. So one of the problem was dealing with something like that, where we have our own on-prem, we call it on-prem SQL server, and how to upload it into cloud. Both of them are the data centers at the end of the day, but just in our terminology, we refer to on-prem as something which is into a limited set of servers versus on cloud, which is on Azure, right? So the problem I was dealing with is, hey, Microsoft has this terabytes of data. How do we make sure that it is uploaded on cloud in reasonable amount of time? So, and the purpose of the data was to draw some business analysis on top of that, like some marketing and other campaign management and all of that. So there's a big problem. Like there is a little bit of the corporate competition problem as well, that whether our team will be able to deliver something or not. At this like terabytes of data we are talking about, it was about like billions of rows in SQL tables. How do you get them to Azure quickly? And it was basic arithmetics that I used to convince the leadership that, hey, like if we build a system where we use the multi-threaded programming, if you know like most of the at least the Windows OS or the .NET, I'm using a lot of terminology. Let me know if you don't get it. But a lot of these runtime systems, they allow the parallel processing, so you can do a lot of tasks in parallel, and you can upload a lot of rows in parallel to the server. It was pretty like fascinating to me how the more the leaders grew, they were not able to understand this. Some leaders, at least the ones who were the stakeholders, who were like kind of the people who could have given me green flag to build that algorithm. But I was still able to explain them in mathematic terms that, hey, if I'm able to upload like 1,000 rows in 1 second, and there are 84,000 seconds in a day, I can get 84 million rows in a day, give or take 100 million roughly, and then within 15 days I can get you like the 1.5 billion rows that you are looking for. And they were not convinced. They were like, prove it. I said, okay. To me, it made sense, but to them, for whatever reason, it did not. And maybe they were very much SQL Server guys. They were very much used to dealing with the big data sets on-prem. They just didn't understand this. I just built some tech and we uploaded it, and it was good. Like within a week, we were halfway there, and they were convinced, and they gave green light. And again, I refer to the corporate healthy competition. So we were kind of given the green flag to build that, and that kind of defined a lot of my learning. I built that was my 0 to 1 product that I built for 5 years. I got a patent on the algorithm that I built. So there's a lot of good thing that like that's one of the examples I use mathematics there. That's where I use the logic and all that to convince management to build algorithm to it's kind of a mix of problem solving and people solving, people problem managing. So a lot over there.
So this has been a really insightful interview. Let's end this with a quick rapid fire round. So I'll just ask you a few questions. You just have to answer quickly.
Okay.
Math or coding? What do you prefer?
Coding always.
So what was your favorite math topic?
In the beginning, as I said, like the basic algebra and the Boolean algebra side by side, but then geometry at some level. And in the senior high school, I would say probability and statistics.
Yeah. What was like the one subject you never really liked in school?
I think everything had importance, but something if I would say is has to be like the history, because a lot of it was most like cramming the dates and stuff. No logic. I mean, there was logic and learnings, but not the way I like logic.
Yeah, makes sense. What has been like your number one learning from learning math, and like which is the one skill that math has helped develop in you the most?
I think I covered a lot, like, but a lot of my decision making is always based on splitting up the problem into small problems, driving data, or using data to drive any analysis and reaching to a conclusion. That shapes a lot of my thinking in day to day life.
Yeah, so thank you for joining us. I think that'll be all.
Well,
Yeah,
it was nice talking to you.
thank you.
Good luck.